Students, good morning to one and all. In the last class, we have discussed the definition of cylinder and the problems of finding the equation of cylinder when the generator and the guiding curve is given. I hope you have practiced them well. Now, in this class, we are going to discuss another important topic, that is right circular cylinder. A right circular cylinder, it is a surface generated by a line which intersects a fixed circle and is perpendicular to its plane. Here, the fixed circle is called the guiding circle, and the normal to the plane of the circle through its center, it is called the axis of the cylinder. Here, the fixed distance, that is PB, this is called as the radius of the cylinder. In the cone, we have discussed the angle, whereas in case of cylinder, we will discuss with radius. Now, the theorem is the equation to the right circular cylinder with radius r and axis of the line x minus alpha by L is equal to y minus beta by m is equal to z minus gamma by n is this one. So, to this, first of all, we should know what is the axis of the line. This is the axis of the cylinder. This dotted lines represents the axis of the cylinder. Now, to prove this theorem, first of all, take any point P, xy, x1, y1, z1 on the cylinder. This point P is x1, y1, z1. Next, A, the point A, alpha, beta, gamma is the point, given point on the axis whose DCs are L by root of L square plus m square plus n square, m by root of L square plus m square plus n square, and n by root of L square plus m square plus n square. So, how we can write this? Just look at here. The axis of the line is nothing but the line equation in symmetric form. Here we can observe that L, M, N, these are the DRs of the line. You know very well how to convert the DRs into DCs by dividing with root of, if A, B, C are the DRs of a line, then the DCs will be A by root of A square plus B square plus C square, B by root of A square plus B square plus C square, and C by root of A square plus B square plus C square. In the similar manner, in this problem, the DRs are L, M, N. Then the DCs will be L by root of L square plus M square plus N square, M by root of L square plus M square plus N square, comma, N by root of L square plus M square plus N square. So, in this way, we can write the DCs like this. Now, if you observe the right circular cylinder, here we are observing one right angle triangle, right? So, here what is P? P x1, y1, z1 is the point, any point on the cylinder. And what is A? A is any point on the axis of the cylinder. And PB, it is the fixed distance, this is called as the radius, right? Now, AP, we can calculate AP by using the distance formula, right? And PB, let the radius of the cylinder be R. This is given in the statement of the theorem itself. Radius is R, right? Now, so AP is distance and PB is the radius. Next, we need to find AB. If you observe this, AB, this is nothing but projection of AP, right? So, projection of AP on the axis. Now, projection can be calculated by using this formula, that is L into x1 minus alpha plus m into y1 minus beta plus n into z1 minus gamma whole divided by root of L square plus m square plus n square. Now, after writing this one, if you observe this triangle, this is a right angle triangle. You know very well that AP square is equal to AB square plus PB square, right? So, we are writing here AP square is equal to AB square plus PB square. Then AP square minus PB square will be equals to AB square. Now, what is AP? What is A? A is alpha, beta, gamma, that is any point on the axis. And what is P? P is x1, y1, z1, that is any point on the cylinder. Now, AP can be calculated by using the distance formula. So, if x1, y1, z1 and x2, y2, z2 are any 2 points, then the distance between them is calculated by the formula root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Similarly here the distance between a alpha beta gamma and p x1 y1 z1 is calculated by using that formula. We are going to get root of x1 minus alpha whole square plus y1 minus beta whole square plus z1 minus gamma whole square, right? Now what is another term here? PB. What is PB here? That is radius of the cylinder. Radius of the cylinder. Radius of the cylinder is nothing but equals to r. Now we have to substitute AP value, PB value and AB values in this equation. Then what happens here? AP square. Since AP is equal to root of this one, AP square value will be x1 minus alpha whole square plus y1 minus beta whole square plus z1 minus gamma whole square minus PB square. PB square is nothing but radius of the cylinder, that is already given in the statement itself, that is r, small r square, is equal to AB. What is AB? Just now we have calculated. AB is projection of AP on the axis of the cylinder. Now AB square, if you take AB square, then L into x1 minus alpha plus m into y1 minus beta plus n into z1 minus gamma whole square by L square plus m square plus n square. Now if you cross multiply this equation, then you will get the equation of the cylinder, right circular cylinder. Here the locus of the, that is path of points, is nothing but the locus. The locus will be like this. Just you have to write x, y, z in the place of x1, y1, z1. That is the equation of the right circular cylinder. Now see once again. So what is right circular cylinder here? Right circular cylinder, it is a surface generated by a line which intersects fixed circle and it is perpendicular to its plane. Here the fixed circle is called as the guiding circle and the normal to the plane of the circle through its center, it is called the axis of the cylinder, and the fixed distance, it is called as the radius of the cylinder. Now the equation to the right circular cylinder with radius r and the axis of the line is this one. So to prove this one, very simple, it is very simple, just to remember this figure APB, right? So here P is, what is P here? It is x1, y1, z1, any point on the cylinder. And A, point A is alpha, beta, gamma, that is any point on the axis of the cylinder. And what is AB here? AB is the projection of this AP on the axis of the cylinder. Now AB, that is projection, can be calculated by using the formula L into x1 minus alpha by root of L square plus m square plus n square plus m into y1 minus beta by same thing plus n into z1 minus gamma by same root of L square plus m square plus n square, right? Now after writing this one, just it is a right angle triangle, so you have to write AP square is equal to AB square plus PB square. What is PB here? PB is nothing but radius of this cylinder, that is equals to R. And AB is the projection, and AP is nothing but the distance between the points A and P. Now by writing this relationship, that is AP square is equal to AB square plus PB square, just you have to substitute all the values, we will get the equation of the right circular cylinder. This one is very important, and in the cone chapter also we have discussed right circular cone. So there you can observe that instead of minus r square, you will get into cos square theta. The same equation you can remember. So while learning, just to compare right circular cone with right circular cylinder, you can observe the difference. Here in the right circular cylinder, you are going to get minus r square, whereas in case of right circular cone, you will have x minus alpha whole square, same equation, y minus beta whole square plus z minus gamma whole square into, completely into L square plus m square plus n square into cos square theta is equal to same thing you will get, right? So here don't get confusion while remembering this formula. Here LHS, if you observe LHS, x minus alpha whole square, y minus beta whole square. That means each term having square and then we are adding the terms, right? Whereas in case of right hand side, if you observe the right hand side, L into x minus alpha plus m into y minus beta plus n into z minus gamma, for the entire term you have square. So don't get confusion while writing this right circular cylinder. Okay, now we will go to the another topic, that is the corollary of this theorem. So corollary of this theorem is very simple. If z-axis is the axis of cylinder, so z-axis is also the line. So if that is the axis, then what will be the right circular cylinder? We will discuss in this corollary. First of all, we have to write the equation of z-axis. You know very well how to write the equation of a line in symmetric form. So we need point and drs, right? We know that x-axis, y-axis, z-axis, all these axes passes through the origin. So that's why here x1 is 0, y1 is 0, z1 is also 0. That is x minus 0, y minus 0, z minus 0, right? Next, we need to write the drs in the denominators, right? So what are the drs of z-axis? 0, 0, 1. If you remember, I think you have remembered the drs of x-axis. If you take drs 1, 0, 0, and for y-axis 0, 1, 0. So here for z-axis, the point is it passes through the origin. So we have written x 0, 0, 0 in place of x1, y1, z1, and in place of the drs we have written 0, 0, 1. So these are DCs. In fact, these are DCs of the z-axis. Now, if you observe this one, here, if you compare this one with the equation of the generator, what is the equation of generator generally? X minus alpha by L, y minus beta, y minus beta by m is equal to z minus gamma by n. So here, what is LMN here? LMN are 0, 0, 1. And what are alpha, beta, gamma? That is point 0, 0, 0. Now, let us recall what is the equation of right circular cylinder. Just now we have proved the equation of right circular cylinder is this one. Very simple. First of all, you have to write down this formula, right circular cylinder formula. So don't get confusion here. X minus alpha whole square plus y minus beta whole square plus z minus gamma whole square minus r square, right? So this is one term into L square plus m square plus n square is equals to L into x minus alpha plus m into y minus beta plus n into z minus gamma completely square, right? Now, so if you put alpha, beta, gamma in the place of alpha, beta, gamma, you have to write 0, 0, 0. Then what happens here? X minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. That means that is x square plus y square plus z square, right? Minus r square is L square plus m square plus n square. Here LMN are 0, 0, 1. Then L square plus m square plus n square will be 0 square plus 0 square plus 1 square, that is 1. So no need to write 1, right? Is equals to, similarly put alpha is 0, beta is 0, gamma is 0, right? And instead of LMN, write down 0, 0, 1. Then these two terms vanishes and we will get only z whole square, that is z square, right? Now, here just simply you can cancel z square terms, left hand side and right hand side. Then x square plus y square is equals to minus r square. It will become plus r square if it comes to the right hand side. So this is the equation of the right circular cylinder with z axis as its axis and radius r. So to prove the corollary, it is very easy. So just you need to remember the equation of right circular cylinder without getting confusion, and after that you have to write the equation of z axis. So the equation of z axis is, so for any line in symmetric form you need point and drs. So for z axis we are taking the point as 0, 0, 0 and the drs as 0, 0, 1. So just LMN are 0, 0, 1 and point on the axis. Any A, alpha, beta, gamma is any point on the axis. Here any point, that means we know known point of Z axis is 0, 0, 0, that is origin. Now radius is R. Simply substitute all these values in the equation of right circular cylinder. Then you will get x square plus y square is equal to r square, which is the equation of right circular cylinder with z axis as the axis of the right. Now we will look into the problems related to this. Find the equation to the right circular cylinder whose axis is, so they have given axis x minus 1 by 2 is equal to y by 3 is equal to z minus 3 by 1 and of radius 2. So here first of all we have to write the given axis. So this is the axis they have given. From this axis you have to write alpha, beta, gamma. If you observe this axis, so always compare the given axis with x minus alpha by L is equal to y minus beta by is equal to z minus gamma by n, right? Then you will get alpha, beta, gamma as 1, 0, 3 and LMN as 2, 3, 1, right? And next they have given radius as 2. Radius means r is equal to 2. They have given that radius is equal to 2. So first of all write down the axis, given axis. From this given axis you need to write alpha, beta, gamma and LMN. LMN are DCs or DRs of the axis and alpha, beta, gamma any point on the axis, right? Now write down the equation to the right circular cylinder. The equation to the right circular cylinder just now we have discussed. So this is the equation of the right circular cylinder. Now substitute LMN values, alpha, beta, gamma values and R values. All the values are given in the problem itself. Just you have to remember the formula of right circular cylinder and you need to substitute all the values. That's all. So here if you substitute x minus alpha, that is 1 whole square, plus y minus beta, beta is 0 whole square, plus z minus gamma, gamma is 3 whole square, minus r square, radius is r is equal to 2, so 2 square into L square plus m square plus n square. Here LMN is 2, 3, 1. So 2 square plus 3 square plus 1 square is equals to L into x minus alpha. L means 2 into x minus 1. Alpha is 1 plus m means 3, right? Y minus 0 plus 1 into z minus 3 whole square. You have to write like this. Now here x minus 1 whole square. Apply a minus b whole square formula. A square plus b square minus 2ab. Similarly y minus 0 whole square is simply y square. Next z minus 3 whole square. Z minus 3 whole square is z square. That is a minus b whole square. You have to apply a minus b whole square formula. That is a square plus b square minus 2ab. Minus 2 square is 4, you know. Here this value is 14. Here 2 into x minus 1 plus 3 into y minus 0 plus 1 into z minus 3. You are going to get 2x plus 3y plus z minus 5 whole square. Here we have 4 terms. We know the formula for a plus b plus c whole square, but here 4 terms are there. So what you have to do is let 2x plus 3y as a and z minus 5 as b, right? Then it will become a plus b whole square. Now this is in the model a plus b whole square. Listen carefully. So here first of all we will do a square. What is a? 2x plus 3y. So a square, that means again you have to apply 2x plus 3y whole square. Again you need to apply a plus b whole square formula. So that is 2x 4x square, 3y square, that is 9y square, 2ab, 2 into 2x into 3y, that is 12xy, plus z minus 5 whole square. Z minus 5 whole square, again you need to apply a minus b whole square formula, that is z square plus 25 minus 10z, sorry here 0z, okay, 10z, plus 2ab, 2 into 2x plus 3y into z minus 5, right? So you have to simplify this one. then we will get the equation of right circular cylinder. So listen once again, it is very simple. First of all, the question is find the equation of right circular cylinder whose axis and radius is given like this. So first of all, write down the axis. From the axis, write down alpha, beta, gamma, that is point on the axis, and drs of the, that is LMN, drs of the axis. And write down what is the given radius and let it be r is equal to 2. After that, write down the equation of right circular cylinder and simply substitute all the values. Here, substitution part is very important, so you have to do the calculations carefully, right? So here, whenever you will get 4 terms, divide two terms as one term. 2x plus 3y plus z minus 5 whole square is there. So 2x plus 3y, let 2x plus 3y is equal to a and z minus 5 is equal to b. Apply a plus b whole square formula. So after that, simplify this one, you will get the equation of right circular cylinder. Well, we have another problems also in this model. We will discuss in the next class. Up to that, practice the theorem of right circular cylinder and the problem. Thank you.